Alright guys, here we got another problem finding this segment of the circle. Again, the segment of the circle is the, uh, um, just like what we did in the previous problem, we have to find the area of the sector minus the triangle. So, what do we got here? I think these are a little bit mislabeled. So, DEF is 120. Sorry, DEF is 120. Which means that, okay, this whole part of the circle, which I'm going to be after initially, is going to be 1/3. So that's 1/3, and I'm going to just presume that it says DF. I don't know what happened with that. It's 1/3 of what? The entire circle is pi r squared. R is 20, so it's 40 pi. Okay, so I'm just going to say it's 40 pi over 3. Okay, now I got to take out this circle. I've got to take out this triangle. Now, we don't want to be tripped up with this triangle. It's another 30, 60, 90. Remember, we said inside is 120. But we're going to split that in half so we can get the height of that triangle. So that's what let's call this. This is point G. This is E. Let's call this point G here, okay? So, okay, what we know is that DF is our 20. It's our radius, okay? Since that big angle up here was 120, we'll cut that in half as 60. There's my right angle. There's my 30, okay? All right, so opposite to 30 is half the hypotenuse, which is 10. And DG is then 10 to the root of 3, because of my 30, 60, 90 relationship. DG is, okay, 10 to the root of 3, that means DF is twice that, 20 to the root of 3, which means my area of my triangle is 1/2 of, okay, the height, which we have here, okay. I don't know what happened to my sizing here. I'm going to change that so I can zoom in that. Okay, let's make it a little easier for us to see. So, sorry about that. So my triangle is 1/2, okay, my base times my height. My height was just determined up there as 10. My base was this DF, which is 20 to the root of 3. So what I have is 1/2 of 200 root of 3, which is 100 root of 3. So my shaded area is what I found previously, 40 pi over 3 minus that, which is now 100 to the root of 3. So that's a good answer, and that's exactly how I'm going to leave it. A lot of detail on that, okay? Listen, this problem 11 is the arc length, okay? Find the arc length of major arc, okay? So what they're giving you here is that this is 45, okay? And they want the rest of the arc length, okay? Which is, okay, if 45 is 1/8, so I know I need 7/8 of the entire circumference of 2 pi r. R is 10, so it's 7/8 of 20 pi. And I guess I can go 4 into each one of those, going 5, going 2, so it looks like I get 35 pi over 2. Okay, let's come down here. What do we know here? Okay, angle C is 25 degrees. We've got tangents which meet a radius at right angles. okay, which makes angle A and B 90. And so, so now we pointed this out previously. This figure is, okay, a kite, and we also know all the angles add up to 360. So we already spent 90 and 90. So ABG is 180 minus 25, right? 155. Okay, let's see. All right, here we go. These were kind of fun. All right. The idea here is that, let's see what we're going to start with. They're going to start with JB, which is said to be 12. And we said that when two tangents, as is the case here, are two tangents from an exterior point are going to be equidistant. So two tangents, JA and JB, from the exterior point J are going to be equal, okay? Which means JA is 12, okay? Because JB was 12. Let's see, what else did they give us? They give us CK is 14, which by the same reasoning means BK is 14. And they give us JL is 20. This whole thing is 20. And we already spent 12 here, so that leaves 8 there and 8 there. So you can add them all up, and that gives you your perimeter, right? Okay, let's do one more, and then we'll do one last video, okay? All right, so here, what we're trying to find is, sorry about that, okay? Here, let's see. We've got this circle of radius 9, this circle of radius 5, okay? We're trying to find, oh, and we also know that the distance between their centers here is AD, which is 20. Okay, so that's 20. And we're trying to find BC. So we'll just label that as X. Now what we do is we remember that the tangent BC to both circles forms a right angle. It forms a right angle, which means, okay, that those radii and the lines containing them are parallel, which means we can shift this segment AD upward and form ourselves a nice right triangle here. Okay, so I'm going to take that out of the picture over here and take a look at it. Oh, what happened? Hold on. Okay, it looks like I managed to come back. Let's take a look here. Okay, so this is my right angle here at B. This is my point C. That's the length I'm after. This AD segment has been shifted up. So here's kind of that point A that's been shifted up. That we know is 20. Okay. Now, this segment right here has got to be the difference between the two radii. Because if I move this dotted segment over, it's the same length over here. So if the whole radius of the large circle is 9, and the radius of the small circle is 5, then their difference accounts for this length here, which is 4. Okay, so now I have two of the sides of the right triangle. This is going to be my x. So Pythagoras will figure that out for me. 4 squared plus x squared is equal to 20 squared. So that's 16 plus x squared equals 400, which means x squared equals 400 minus 16, which is 384, and x equals the square root of 384. You can simplify that if you